Have you ever been building something in the cloud and had that little voice in the back of your head ask, am I doing this the right way? Well, today we are diving into the answer to that exact question. We're talking about the AWS Well-Architected framework. And trust me, this isn't just some boring document. It's a blueprint for building amazing things, a guide that's been distilled from looking at thousands of real-world systems on AWS. So let's get right into it. So, first things first, why do we even need a framework like this? It's because building on the cloud is kind of like being handed the keys to a spaceship. You have incredible power, but also a dizzying, overwhelming number of buttons and levers. Every single choice you make, from which database to use to how you set up your network, has real, long-term consequences. So how do you navigate all that complexity without accidentally trapping yourself with design choices that are expensive to fix or, worse, insecure? And this complexity isn't just about the tech, the servers and databases. It's a whole ecosystem of different roles and different types of services. You've got the people using the cloud, the companies providing it, and all the different ways you can consume it. Are you managing the raw virtual machines yourself, or are you just using a piece of software that runs on top of it all? Figuring out where you stand in this web is really the first big challenge. And that's exactly why AWS created the Well-Architected framework, to help cut through all that noise. Now, this isn't just some academic theory. This is a collection of practical, battle-tested best practices that they've gathered from reviewing thousands upon thousands of their customer systems. It's pretty much their definitive answer to that big question: how do we build great things on AWS? What's really crucial to understand is that this is not a rigid set of rules you have to follow or else. Think of it more like a guide, a consistent way to look at your system and measure it against what works best. The whole point is to keep getting better, to treat your architecture not as some static blueprint you build once and forget about, but as a living thing that you're constantly learning about and improving. So the entire framework is really built on this foundation of 6 core concepts. AWS calls them pillars, and they are for sure the fundamental principles that hold up any successful, well-designed system in the cloud. Yep, 6 of them. And when you put them all together, they cover every single critical aspect of a modern cloud application. I mean, everything from how you run it day to day to how it survives a failure, all the way to how much it costs you to run. So let's take a look at each one. First up, we've got operational excellence. This is all about the how. How do you actually run your system in production? How are you monitoring it? How do you respond when things go sideways? And how do you manage changes? It's all about making your daily operations as smooth, predictable, and automated as humanly possible. And a really key idea here is to stop doing these massive, high-risk, big bang updates. Instead, the framework says to make small, frequent, and, this is the important part, reversible changes. Why? Well, think about it. If one of those small changes breaks something, the blast radius is tiny, and you can just flip a switch and roll it back. It protects your users from huge outages. Next up is security. And this is a huge one. It's not an afterthought. AWS puts it right at the front. It's all about protecting your data, your systems, your assets from threats. This means being really deliberate about who can access what, how you can detect potential security issues, and what your game plan is if an incident does happen. And if you take away only one thing about security, let it be this: the principle of least privilege. Put simply, don't give anyone, or anything, like an application, more permissions than it absolutely needs to do its job. That one single practice will dramatically shrink your attack surface. Pillar number 3 is reliability. This is all about building systems that expect and can withstand failure. Because let's be real, in a dynamic environment like the cloud, things can and will fail. A reliable system isn't one that never fails. It's one that can automatically recover from those failures and just keep on working for your users. And a huge part of being reliable is having control over how you introduce changes. Every time you make an uncontrolled change, you're basically rolling the dice with your system stability. But when you implement a deliberate, controlled process for deployments, you're replacing that gamble with predictable, stable results. All right, next we have performance efficiency. This pillar is about 2 things: speed and using resources smartly. It's about picking the right tools for the job, but also building an architecture that can grow and handle more traffic without slowing to a crawl or costing you a fortune. And this really gets to the magic of the cloud: elasticity. Instead of buying a gigantic server just to handle your busiest day of the year, you build a system that can automatically add resources when traffic spikes, and, just as importantly, remove them when things quiet down. You only pay for exactly what you use, when you use it. Which, of course, leads us perfectly into cost optimization. This is all about being smart with your money. It means really understanding your spending, hunting down and eliminating waste, and making sure that every single dollar you spend in the cloud is actually delivering real value back to the business. And the key to this is visibility. When you can actually trace your costs back to specific features or products, you can make way smarter business decisions. All of a sudden, your cloud bill goes from being this big, scary, mysterious number to a powerful tool for strategy. And finally, we have the newest pillar, sustainability. This one is about building with the bigger picture in mind, about minimizing the environmental impact of the technology we build. It's about being efficient, not just to save money, but also to be a better steward of our shared resources. And here's a super simple, practical example. Just by choosing an AWS region that's physically closer to most of your users, you shorten the distance the data has to travel across the network. Not only does that make things faster for them, but it also reduces the total amount of energy consumed. It's a classic win-win. Okay, so we've seen the 6 pillars. The theory is great, but theory is one thing. How do you actually use this framework? Let's talk about putting this into practice. Before you can do anything, you have to understand this one absolutely fundamental concept, the shared responsibility model. Think of it this way. AWS is responsible for the security of the cloud. That means the physical data centers, the hardware, the core networking, they've got that covered. But you are responsible for security in the cloud. That's your data, your access policies, and how you configure all the services you use. The framework is what helps you handle your side of that deal. So the practical application is this 4-step review process. You use a free tool from AWS, and you go through a series of questions about your system, all broken down by those 6 pillars. The tool then compares your answers to AWS best practices and spits out a report that shows you where your high-risk issues are. From there, you build a plan to fix them. And the most important part, you don't just do it once. You make it a continuous, regular part of how you build and run your software. So we've covered the what and the how, which brings us to the big question. The most important question, really. What's the main takeaway for you and your team? This all matters because the framework isn't just some academic paper. It's a practical toolkit for building better stuff. When you apply these principles, you end up creating applications that are more reliable, more secure, and faster, all while keeping your costs under control. Ultimately, it helps you stop guessing and start making smart, informed, data-driven decisions about your architecture. So I'll leave you with a question to chew on. Thinking about your own projects, your own systems, what is one small, simple thing you could do today inspired by one of these pillars that would make your workload just a little bit more well-architected?